Hi, I'm Simcha Lefton. Stay tuned. Taped with Rabbi Dog is next.
Simcha developed an interest in the weather when he was in preschool. Every morning when he was about 4 years old, he would wake up around 6:30 a.m. and listen to the weather on his FM radio, and later shared his own forecast based on that with his father on the phone. Throughout elementary school, every evening when he came home, he would do a mock broadcast as a meteorologist. He started his podcast, Weather with Enthusiasm, in December 2020. And welcome Simcha to the show. Simcha, welcome. Glad you could be here. I've had many weathermen, professional broadcasters from television and radio on my television show before, but never someone who did a podcast about weather. And you are kind of a weather guru since you were a young child. Probably had illusions of not doing what you've been doing for a living and going to rabbinical school and so on and so forth, but being on television and being a meteorologist for a living. What is it about weather that interested you at such a young age? What is it? Yes, I want to know if it's cold out or warm out. I want to know if there's ice on the ground or not ice on the ground. I want to know if it's going to be so hot and sunny that I can go swimming today because the weather is so good. How do you get into it and learn about all the things you learn about and know about when it comes to weather patterns and climate change and so on and so forth? Where does that come about, and how do you start on something like that?
So with the weather, I just love how every day it's a new story with the weather. There's always something new developing. Either that or it's just the opposite. Actually, it's the opposite which is most fascinating to me, when there's tremendous consistency, like a consistent hot and humid weather pattern in St. Louis in the summertime, and when things are always changing during the rest of the year. I also love snow. It could be, as a 4-year-old, I was extremely excited to have school canceled. In St. Louis, school gets canceled all the time whenever there's snow. It's not like here in Chicago, where my wife told me that she never had any snow days except for maybe one growing up. Every single year I had snow days growing up, except for when I was in 4th grade. And when there's just several inches of snow, 3-4 inches of snow, they cancel school there. So that probably was the original inspiration. When I was 4 years old, I woke up, it was all white, and I was told there's no school. But there's a lot more than just that. But snowstorms happen to be one of my most fascinating parts of weather, parts that I find most thrilling, and nothing is more heart-racing than hearing an alarm from the weather radio issuing a winter storm warning. That's great.
It's exciting for you.
Yes.
Not for me. So when you study weather patterns and barometric pressure and all those things, which I don't even really understand, you can kind of almost tell by a weather map and things like that where the weather is going to go. Now, you told me something interesting before the show about tornadoes in the Midwest and the South, and I want you to share that, because I don't know how you know those things or you would learn those things, but I don't think anybody who's watching knows these things. Tell us about the change in tornado patterns.
So Tornado Alley is a place which is around in Oklahoma, Kansas, in that area. There's a certain number of tornadoes that happen there every year, but Tornado Alley is actually moving east. So places in Kansas, the number of tornadoes that are happening in Kansas are actually going down. There's less tornadoes there than what there used to be. Whereas a place like Memphis, Tennessee, that's now included in Tornado Alley. So people don't know really why it's happening. Some people have a theory that because of the drought, which has been occurring in the desert Southwest for a very long time, that's starving the environment for moisture in the plains, and it's reducing the number of tornadoes. So they say that climate change could be a factor in this because of the desert Southwest. People say that the drought is a result of climate change, so that could be one reason why the Tornado Alley is moving east. That's possible.
It's a very, very interesting thing. So let me ask you about the weather patterns now. Now, here in the Chicago area, we went through at the end of December, beginning of January, very, very cold weather. Very cold weather, below zero. at some points, and certainly a deep freeze for days and days. And then all of a sudden, that broke, and we go up into the 40s, 50s, 60s for a couple of days, back down into the 40s and 50s, and hovering around the 30s and 40s, upper 30s and 40s now for 3 to 4 weeks. How does something like that happen? Where did that cold come from? Why doesn't it last? And all of a sudden, why don't we go to like normal weather patterns, what we call the average temperature for this time of year, and get to these warmer temperatures that we've been going through, and have them stick for weeks? How does that happen?
So it's a very interesting thing what you brought up. I remember back in the mid part of December when they saw this bitter cold coming. They said this. The European computer model showed it really first. It showed this amazing cold outbreak coming. It would actually be colder in St. Louis than here in Chicago, and I kept looking at it, and this is before anyone was really talking about it. I was just like totally amazed at what's happening, and I was thinking, is this really going to happen? And okay, then it happened. Then I was thinking on my podcast, what should I say, and what's going to happen after that? So I remember learning about this. There's this theory that the weather works in 11-year cycles because the solar storms in the solar cycle works in 11-year cycles. So for example, during the summer of 1988, there was a major drought in the Midwest. The summer of 1999, there also was a drought. And there's a lot more comparisons like that. So the bitter cold outbreak in late December, that was being compared to December 1983, but they were also comparing it to the Arctic outbreak of December of 1989. And I remember in 1989, I remember it being extremely cold, and then came January, all of a sudden it became mild, and it remained mild, and 1990 ended up being one of the mildest years for the St. Louis area. So I was wondering, is that going to happen again this year in January? And it did. And I don't really know why it happened. I know that a lot of times these Arctic outbreaks are a result of warming that happens in the stratosphere, which you'll see in the National Weather Service forecast discussion. They refer to it as an SSW, a sudden stratosphere warming. They don't know why, as far as I know, they don't know why all of a sudden there will be a warming in the stratosphere. Some people say it could be because of global warming. They don't know why. It doesn't always lead to an Arctic outbreak. It leads to an Arctic outbreak about 70% of the time. But in the year 2019, it did not lead to an Arctic outbreak. But what happens is when there's warming in the stratosphere, it weakens the polar vortex, the jet stream which is around the poles, and when that weakens, it is no longer able to keep the Arctic air locked up over there, and the Arctic air starts to come down south. But this past January, it's been very strong. The polar vortex, it's been very, very strong. When it's strong, it remains locked up. And so that much I can tell you, that the reason it's been locked up is because it's been very strong. But if you want to know why it's strong, at a certain point, there's going to be like no answer. But they said there has been a warming again of the stratosphere, and it takes about 3 weeks before we see its effects. And the current thinking right now is that in the first week of February, we are going to see another major Arctic outbreak.
So that's just coming up very soon, around the time that we're probably airing right now. Tell me about so you grew up in St. Louis. So in my mind, living in Chicago, we have, from the time I'm very young, we kind of have in our mind that if you go a little bit north, if you go into Minnesota, it's always going to be 20 degrees colder. They're always going to have 6 to 8 more inches of snow than we're going to have. You go down to St. Louis, it's going to be 15 to 20 degrees warmer, and the same situation, they're going to have, if we have 8 inches, they're going to have 2 or 3 inches maybe of snow, but the temperature is going to be warmer, it's going to melt faster. Then if you go east a little bit and you go towards like Atlanta, where you're approaching the East Coast, but not there yet, you're also going to be about 10 to 20 degrees warmer most of the time than it is in St. Louis, and they're just going to get a touch of snow when we're getting a few inches in St. Louis and more inches in Chicago, and then of course we get to Florida. So right now in Florida, for the last few weeks, outside of the last few days maybe, they've had cold weather also. Is that cold weather coming from what was here before? How does it work that southeast, that's usually at this time of year a very warm climate, gets cold weather, but we also had very cold weather right before. Does it flow down southeast, or is it a completely different flow that runs down to the south?
So I was following the weather a lot back in the beginning of January, at the end of December during that Arctic outbreak. And back then, Orlando, Florida got very cold. It dropped into the low 30s, and that was really a result of the Arctic outbreak that came from the north. It came through here and went down there. But I will say there are occasionally during the year, there are times, I think generally it's more common in the spring or early summer, let's say the spring, where you can get really warm temperatures up north, and then down in Florida, or this past summer it happened in Texas. It was just a closed low pressure system just situating itself over there, and it just was cloudy, and temperatures were in the upper 60s over in Amarillo, Texas, and temperatures were in the low 90s in Alaska. And that was towards June 26th, that's when that happened, and the temperatures were very, very warm across much of the north, and then it was really cold in Texas. So you have stuff like that because of these closed low pressure systems, which greatly reduce the amount of solar insolation which is reaching the surface, and the precipitation also.
Does that have something to do with Arctic melting that everybody's worried about, and the Arctic ice melting, and how that's affecting wildlife?
So I don't really know what the connection is between the Arctic melting and temperatures going into the 90s in Alaska. So really, this amount of solar insolation that reaches the surface in Alaska around June 21st is the highest in the entire world, and it's always been that way around June 21st, because even though the sun's angle is very low in the sky, but the days are 24 hours long. So the real question is, why isn't it in the 90s everywhere in Alaska? And that's because it takes weather about 3 to 4 weeks to respond to the strength of the sun. So since 4 weeks before June 21st, the sun was stronger elsewhere, so that's where the real heat ends up being. But occasionally, it seems like we get these air masses that almost like transport themselves into a new latitude, a new degree latitude, as if like it was there for months. Let me just give an example. Like in the end of June 2021, there was this Northwest Pacific heat wave. This heat wave where the temperature hit 121 degrees in light in Canada, and it's almost like there was an air mass over the desert Southwest that just picked itself up and then dropped itself in Canada, just picking up where, as if it was the desert Southwest, which the sun is actually, there's more solar insolation in Canada that time of the year, June 21st, there's more solar insolation than there is in Arizona. It's very hot in Arizona. There's tons of solar insolation, but it's a little bit higher when you go into southern Canada. So it makes sense, it kind of makes sense that it would be even as hot, or should be even hotter there in Canada. The only reason it's not is because it doesn't have those 1 to 2 months of preparation beforehand. But somehow, if you can get that air mass down south to just skip, somehow just like transport itself up there, it's all prepared down south, and it just comes, just locks itself in up there. So then the heat from the desert Southwest comes up there into Canada. I've always wondered, will there ever be a time when something like that's going to happen in the Arctic, where the solar insolation is super high? Well, one could just imagine, like, you could barely imagine if you were to hear, like, today the temperature was 121 degrees in Barrow, Alaska. If you were to hear such a thing, people would think the world is coming to an end or something. But is it really coming to an end? Or does this almost make sense? It could happen in light in Canada, so why can't it happen up there on June 21st when the days are 24 hours long, and as long as there is no snow on the ground, if there's snow on the ground, so then that already reflects 90% of all the insolation back up into outer space. We had actually in Antarctica, there was an unprecedented heat wave that took place last March in 2022, around like March 18th or 19th, where the temperatures were 90 degrees above normal over there. 90 degrees above normal, when normal highs were around 60. Well, the Washington Post reported being 69 degrees above normal, but the satellite imagery temperatures showed 90 degrees above normal, where temperatures were normally around 65 below zero, and the temperature temperatures were around zero, and there even was the highest temperature for the year. The highest temperature ever in one of these stations, I think it was the Russian station, was 10 degrees, and the previous highest temperature was 27 below or something like that. Whereas one place it was the zero was the highest, and 27 below was the previous warmest, and the other
all
place,
Fahrenheit, right?
All Fahrenheit, right? All Fahrenheit. And so even climatologists, they say that climate change does not explain that. It was too magnificent of an event, and all of their computer models, the climate change computer models, which no one ever forecasted this. So they don't really they have different explanations for why that happened. The closest thing they are able to say, if they're going to connect it to climate change, is that if something's not done about climate change soon, some events like that might happen more frequently in the future. But sometimes there's just things that are just like freak occurrences, which there's a meteorologist, Bill Mass. He's I think he might be well known. I happen to be a big fan of his. But he said that the Pacific Northwest heat wave was not, he thinks the more extreme the event, the less connected to climate change it is. So, and the more connected to just a freak occurrence. Climate change might have increased the degrees by a couple degrees in the Pacific Northwest heat wave. So instead of 121, it would have been maybe 119 or something like that if it wasn't for climate change. But the actual event would have happened nonetheless. So going back to the original question over here, if climate change is connected to the heat in Alaska, so any of these phenomenal events, it's hard to. The more phenomenal it is, the less connected to climate change. That's what I think. That's what he said, and I think that makes a lot of sense. Mm-hmm. And 90s in Alaska, if it's happening in the end of June when the days are 24 hours long, I don't think the climate change is connected to it, but it could be. I don't know. It could be.
All right. So I do have a few questions I wanted to ask you directly. One is your podcast. What is the most, because you get excited about weather, what's the most exciting event you actually have reported on your podcast that really your listeners have said, wow, I'm so glad that he shared that with me? What is that exciting thing that you've reported?
So it's hard to get feedback from listeners, but the Pacific Northwest heat wave was something which was just totally amazing. And even before it happened, when
was that again? Tell me.
This was the end of June 2021. I remember this podcast I made, actually, it was on Shiva Asar B'Tammuz, the fast day. It was June 27th, I think, and they were forecasting that week temperatures which were just, it was like dreaming. It was like totally, it didn't feel real what was happening. And that's even what, if you read, that's what the meteorologists were going through themselves. They were pinching themselves to make sure they were still alive. I remember Bill Mass said if it wasn't for the fact that every single computer model is forecasting the same thing, we would dismiss these forecasts. Sometimes things like that happen. You'll have in Denver, Colorado, there was the GFS model was going wild in a certain storm forecasting 50, 60 inches of snow. Everybody knew, you just dismissed that model, but nonetheless it brought a lot of attention to that snowstorm, and they went with the European computer model. But over here, all of the models were saying the same thing, 110, 115 degrees. It just kept going up and up. And not only that, but just like in snowstorms, a lot of times you'll have forecasting 1 to 3 inches, the models went up, now it's 3 to 6, now it's 6 to 12, now it's that. You'll never hear that in temperatures, except this one time. You'll never hear in temperatures they were forecasting at 84, now it's up to 98. It doesn't go like that. But in this particular heat wave, that's exactly what it was like. It was going from highs in the low 90s, upper 90s, mid hundreds, low 100 teens. And they said actually they were able to figure out exactly what it's going to be 5,000 feet above the surface. They said they have that all figured out, but they can't figure out what's going to happen on the surface because the air is so dry, they just don't know what's going to happen. And speaking of dry air, actually, there was some city there that actually was not dry at all. It was very humid, and I have to go back and listen to that podcast to hear what the name of that city was again, because that was the most fascinating thing to me, and I always wanted to look into it. But there is some area in Idaho that apparently does get humidity around there, and I'm not sure where it comes from. But I think there's a river there, and that's where it comes from. But even in that area, it also was extremely hot. I think that was the most magnificent event.
Okay, all right. So now another question for you. Teach us something. Light effect snow. You know, if you go into northwestern Indiana or southern Michigan, along Lake Michigan, they have the phenomena of inches and inches and inches often of lake effect snow. Whereas in Chicago, we might get a half an inch and call it lake effect snow. They're getting 6 inches, 7 inches. What is lake effect snow? What does the lake do to the clouds that causes it to snow where those clouds didn't snow when it was over here? How does that work?
So what happens is there's just like a large jar holds more water than a small jar. We know that heat expands, so the warmer it is, the more moisture the temperature is able to hold. So if it's 70 degrees and the relative humidity is 100%, that means the air temperature is holding as much water vapor as they can possibly hold at that temperature. So if the temperature was forced to drop however many degrees, something's going to have to happen. There's going to have to be some type of condensation, which could either be a super cooled cloud. It doesn't have to be that it's going to rain, but it usually does mean it's going to come out in the form of precipitation. So that's what's happening with the lake effect snow showers. So you have very cold air. Let's say the temperature is 10 degrees or something, and it's blowing over water where the temperature is 35 degrees. So the air temperature is just above 35 degree water is also about 35 degrees, and it's also the dew point, or the relative humidity is about 100%, it's about 35 degrees, but the 10 degree air, it can't hold the amount of water vapor that 35 degrees can hold, so it automatically just, it comes out as condensation, and it just comes out as very heavy snow. This year in particular, at the end of November, that was the first one in Buffalo, where just feet of snow were falling down. One area got 81 inches of snow within just a few days. 65 inches of snow fell in just a 24-hour period in that area on a Friday, and it was just the ideal situation for lake effect snow. There was no ice on the water yet. And usually, as we go through the winter, ice forms in the water, and that greatly reduces the amount of lake effect snow that could fall. But in the end of November, and even in January, again it happened in Buffalo. Again it happened, like it was unbelievable. That one actually was associated with a real storm system. In the beginning, it was a real storm system. They saw 2 inches of rain before they got the lake effect snow, but they also got an enormous amount of lake effect snow. But that's one of the reasons why it happens there. So Chicago, it doesn't happen because the winds by lake effect snow, the winds they have to blow over the water, and when the cold air comes in, the winds are blowing from the west or the northwest or sometimes the north. When the winds are blowing from the east, it's usually not blowing in the cold Arctic air. So Chicago, the lake is to the east of Chicago. So when the cold air blows, it's coming in from the other direction. Chicago has something else, which is called lake enhancement. So it's not lake effect snow, but what it is when we do get storms that come here, the Chicago area will see more snow than the surrounding areas because of the northeast.
The surrounding meaning the suburban areas.
Right, the suburban areas. Because if it's December or January, in November the lake is already too warm that the snow might even be less in Chicago because some of the snow might fall as rain. But when you get into winter, when the lake is very cold, so the winds blow in off the lake, usually right before the snowstorm comes, the winds are coming from the northeast, they're coming right off of the lake, and it picks up a lot of moisture. It's not like a lake effect snow, but it picks up a lot of moisture, and the snow is heavier in the Chicago area. So for example, during the Groundhog's Day blizzard in 2020 and 2011, so a lot of the surrounding areas, the snow ended at 19 inches or 20 inches, or 18 inches, something like that. In the Chicago, the following morning, it was still snowing, and they said an additional 2 to 4 inches is expected. That's all from lake enhancement. There also was a storm in the year 2021, in the winter of 2021, where O'Hare Airport got 10.2 inches, but in West Rogers Park, it was 18 inches. Evanston also 18 inches. That's all from lake enhancement. But Chicago doesn't really get the lake effect snow. It's 5 inches tops.
I told you, you'd teach me something new. It's amazing. Quick question, because we're running out of time. But what do you think of the Farmer's Almanac? What do you think of the Farmer's Almanac that comes along and predicts, this winter is going to be the worst winter, this winter is going to be a light winter, and sometimes they come true and sometimes they don't? Do they base it on anything, or is that just kind of a wives' tale and like looking at the stars?
So they claim to have 80% accuracy, and they claim that Part of they say it's a secret formula. They don't tell people what it is, but part of it is the 11-year solar cycle, and then part of it is looking at the ocean currents like La Nina or El Nino, and also they say they could be between 1 to 2 days off, and then if you look at it, it's just they have a pretty good chance of getting things right because they forecast with everything within 3 days, so then you could be 1 to 2 days off. All I know is that I was told, I don't know if this is true, but back in the 1800s that the Farmer's Almanac was so accurate that if you went to court, you were able to prove what the weather was based upon what it said in the Farmer's Almanac. And that's gotta be something someone made up, because that's just, nothing could be more ridiculous than that. But this most similar thing I have found to that is the European computer model nowadays. That thing, a lot of times, especially here in the Midwest, it's just so accurate. It's just totally amazes me. And I think of what people said about the Farmer's Almanac when I look at the European computer models. But even that, we know you can't even use that when you go to court to say, oh, I know it was sunny because the European computer model said it would be sunny. So I don't really know. I used to love the Farmer's Almanac. I used to buy all of them. I found it fascinating, and I would read it. And I always wanted it to be right. I would try to make it come out right, and but I don't know. I don't really know what to say about it.
Very cool, very cool.
The following is a 1-minute trailer for this podcast. Following is a winter storm watch in effect from the Omaha, Nebraska National Weather Service. Several additional feet of snow is expected by Monday morning. People were reporting frost quakes. These are earthquake-like tremors. We have a powerhouse typhoon which has developed off in the Pacific Ocean. A big shockaroo to many of you. We have parts of the world that are so hot right now. Temperatures are expected to go into the low 130s. Recorded temperatures during heat bursts have reached well above 104 degrees. It's a rare atmospheric phenomenon. We're going from one extreme to the next extreme. Feet of snow are falling in Japan.
Oh my gosh.
Just Google weather with enthusiasm and they're all gonna come up.
For thunder and for lightning and the rainbow in the sky, for mountains and for oceans or a river running by.
You've been listening to the podcast Weather with Enthusiasm.